Hello everyone. Welcome to the first video tutorial of this course. We figured we'd try this out, see how it goes. Yeah, let's hop right into it. So I have my file open here. This is the same one that you guys downloaded. No changes made. Just gonna pre-make it. So you'll notice there's a new sample, week 4 starter. And within it, I have made a few changes. There was one specific change made in scene.h, and that is I added the ability to remove entities. That actually doesn't have anything to do with what we're doing today, but it just had to do with something I did for me. You should have the ability to remove entities. It's a pretty important skill. And also it's important for this. I wrote a that environment generator that I talked about last week. Oh, I never set as startup project. That environment generator that we talked about last week. I made improvements, and now this is all you need to do to generate an environment. These are just vectors telling them where to avoid, telling everyone else where to avoid, and telling them where to spawn. And technically I could write those all in here, but as you can see how long these are, it would make these lines ridiculously long. Plus, if you do it this way, you could theoretically add a thing up here, have them be modified. But yeah, you can actually just swap out these objects for anything, as long as you have them obviously downloaded in the models folder. One thing that is going to get a little annoying today is the fact that your shaders, your project needs to be cleaned whenever you rewrite shaders for some reason, because the shared assets folder, like, it just won't use the right ones. But yeah, so this is the generator. It'll just generate a random forest. I thought it was cool. Feel free to use this. I don't have any rules for it. It was just fun to make. Plus, it allowed me to make my own improvements to things in general, to my future tutorials based on things I had to be able to do to make this. So it was nice. Yeah, feel free to use it to make your own environment. Yeah. So all we have in here is same as last week, your test buffer. So technically, we can just go up here, load in, like this already is a post-processing shader. Doesn't do anything, but it is a post-processing shader. Technically, we can just load in other post-processing shaders, go down here, and bind them and have them do things. But we don't want that. We don't care about that. That's technically you can do that for any post-processing effect you want. However, that's not what I'm going to show you. What I am going to show you is in graphics post, I have added 6 new files, 3 new headers. So we're going to start in PostEffect. And so PostEffect is your base class with this. It is the class that is going to be referenced for all of your other post-processing effects. This just makes your life real easy, because later on your other, like, creating new effects is gonna be pretty simple because of it. Like, it's gonna take seconds instead of a while. For those of you that are avid, you'll notice that these use a format. You'll see later. You'll see later. But point is, the way that this is written is, it's better if I show you. I do have this planned out. I just like to get active myself because I get excited about writing well, shaders and effects. Like, shaders are what I started with. So I'm just leaving a comment. I'm gonna continue to write comments even though I'm gonna be giving live voiceover. So what we're writing here is our initializer. So width, height. This will apply the effect. This will also be virtual. And so what we'll do is we'll pass in the previous buffer. And the reason for this is, say you're applying a whole bunch of effects that need to be applied over and over again. What's the best way to show this? So if I open up paint.net and open up well, I have an idea. I have something that I was meaning to show you guys anyways. Okay. So let's say you open up this. So you want to apply grayscale. And, well, actually, grayscale doesn't leave much to work with. You want to apply sepia. And then you want to hue shift it. So now you've got a sepia-looking background, or it's got like the sepia type. I don't know what to call this. Styling, shading, like coloring. And now you can switch it to like purple. So it would be different, or let's look at how far I hue shifted it. So it's negative 140. This is negative 140. So what if I undid sepia and instead went to hue? Look at this. This is a mess. This is not what we wanted. If you do this and then sepia it, you don't end up with what you want. So you need to do it in order. So we sepia it, we hue shift it. Now you've got this purple effect going on. What you need to be able to do is, so this is your first image. This is your first buffer. This is where you draw your 3D object. So you need to be able to take this image and pass it on to your sepia effect. So your sepia effect can apply an adjustment to this image. And then you take this picture and you send it onto your hue shifter. And now you've got this beautiful image. But if you had done it in a different order, and who knows, this may be what you want, you'd end up with this, and you sepia it. Doesn't really look that different. I think this area gets a little brighter if you do it the other way. But point is, you can make that decision. But the reason why we pass in the previous buffer is so that we can take that image from the previous buffer where we rendered or where we applied a previous effect, and we can continue with it. So in that case, the reason why this is not a pure virtual is that we are still going to be able to draw with the base PostEffect class. In that sense, we could easily rename this to basic effect. Because all that this is going to be is this is just in case you ever write an effect that it's impossible to draw to screen the natural way. 9 times out of 10, I don't think in any of the effects that I've written with this system, I have ever had to override draw to screen. But it is there as an option. Reshapes. And this also makes applying things like bloom really easy, because bloom requires 4 buffers, 2 of them need to be half-sized, and so on and so on. And probably in another video, I will show you guys how to do bloom, because I know that is a requirement for your GDW. But yeah, so like, for example, imagine having to do bloom and every time the screen resizes, having to go in and manually resize each buffer in bloom. Or you could have a single function that just reshapes it for you. Oh, sorry, that goes to the frame buffer reshape right now. Don't know why. I think IntelliSense is just confused. Now we have to clear the screen. It's still very important. Clear all of our buffers. Load. Fine. Buffer. Bind. Textures. Void. So all these do is, obviously these do the exact same things that we already have, but they work for this. So all that these functions will do is call the individual frame buffer functions that we've already written. That's why they'll be pretty empty. But they make our lives easy. So the reason why this is protected is because this is going to be a base class. So we don't want them to be private, because if they're private, they won't get inherited. We want these to be inherited, very much so. We are actually going to use manually allocated memory here. If you would like, again, as I've said in the last tutorial, I'm not particularly familiar with smart pointers. If you are more familiar with smart pointers, by all means, implement a smart pointer system. For me, I'm not the greatest at it's not my forte. That's all. That's all for this thing. So we just select all of it, control period, create declaration / definition, and then we go to PostEffect.cpp. We can close this. Like that. But yeah, so the idea with this is to make your lives, ignore that, is to make your lives easier. And so what we'll do here is set up frame buffers. Yeah, it's pretty simple. We're just gonna set up frame buffer. For this post effect, we don't actually need multiple buffers, so this is just, you know, I don't know if you guys have ever done the index is equal to, like, for a vector, you do like vector dot size -1. If you store the index before you push it back, you don't have to do -1. It'll just be right. So push back, new frame buffer, buffers, index, add color target. So because this is a basic one, we want RGBA8 as the format. Buffers, index. And because we have a skybox, we need a depth target. If your basic buffer does not have a depth buffer, it will not render things correctly. Things will be screwy, which is not something that you want. And then do index equals int. This way you don't need to make another one, and these will all go away at the end. Shaders dot pushback shader create. Shaders index load shader part from file shaders pass through vert glsl gl vertex shader, and then Control C, Control V, change this to GL fragment shader. So this pass-through shader that I've written here, I will show it to you in just a second. It was included within your starter. It was a very simple shader, which is why I didn't get us to go through it. So I will go through those. Let's see if it'll let me open it. This is a sad. So we got samples, resources, shaders, host. Nope. Those are empty shaders. Also, for anyone that wants to do shader editing in VS Code, if they have it, or I don't use the Visual Studio as my shader editor, but if you want to do shader editing in Visual Studio Code, this actually supports shader languages. So, like, it'll automatically tell me stuff like that. It's pretty great. So as you can see, all this pass-through.vert does is it takes in, remember that plane that we set up? We go framebuffer.cpp. We set it up so that attrib array 0 is the vertices and attrib array 1 is the UVs. So location 0, vertices, location 1, UVs. And the interesting thing about this is we don't actually change a single thing about the in position. So this makes it so that the plane entirely covers our screen no matter where you rotate, no matter where your camera's facing. or how zoomed in it is, or anything. So then over here in our pass-through.frag, we output it at 0, we input it at 0, we output frag color, we input our screen texture, which is binding equals 0, uniform float, we have our transparency. You can change the transparency just using this uniform. There are some effects that want you to have this. Can't think of any off the top of my head, but it could be useful. It's just something I have in there just in case. You read in the texture, you set the out color to the texture. It basically, a pass-through shader just passes a texture through onto a frame buffer, and that's it. That's all. That is all. There is not a whole lot of code in this video. And I almost definitely won't be doing the same level of information that I did in the last one. So I'm not sure if you have noticed, but when we do in graphics, when we bind things, we unbind them in reverse order. So buffer, so we've bound the shaders, and then I wrote unbind shader. So up here, I'm going to send in previous buffer, bind color as texture. So this will be the it'll be the previous buffers. So for the basic effect, we take in the previous buffers index 1, like this is the first buffer in the index. It's guaranteed that there's always a buffer there if the effect exists. The first color buffer, because it's guaranteed that'll always exist. And the first texture, and we place it in the first texture slot because that's how the pass-through shader works. It needs to be in the first slot. And then we just do buffer unbind texture, and it just unbinds anything that was in texture slot 0. And then we just do buffers 0, which is our only buffer, render to full screen quad. And this applies the effect. It applies whatever shader we have loaded in. In the case of basic buffer, all it does is apply a simple pass-through effect, which doesn't change anything about the image. It just turns it into it basically takes whatever your frame buffer before was, whatever like the buffer before was, and just passes through the data without editing it at all. So for DrawToScreen, it's a little different. Just bind shader, unbind shader, bind color as texture, unbind texture, and then buffers. We draw full screen quad. This just draws that image, or that plane on top of our screen, draws it so that our screen now shows the correct stuff. As for reshaping it, well, remember we already went through the trouble of writing a thing specifically for that. So buffers, I've already written it. It's already done. Clearing? Oh, would you look at that? Yet another thing that we've already written. So buffers, clear. Unload is going to be the most advanced that today gets. So we check if it's not equal to null pointer. If it exists, we unload every buffer to make sure that the memory is cleaned up. And then we delete, or sorry, make sure that the OpenGL memory is cleaned up. And then we delete the dynamically allocated buffer to make sure that like the memory that we've set aside using dynamic allocation is cleaned up. And then we set it equal to null pointer. As for cleaning up the shaders, if you just do shaders.clear, this is why smart pointers are better. This right here specifically is why smart pointers are better. If you do this, the smart pointers will delete themselves. As long as nothing's referencing a smart pointer, it'll delete itself. So we bind it. Oh, sorry. Technically, you could also write that, but it's easier to just write bind framebuffer, gl framebuffer, gl none. Buffers, index, bind color as texture. And then we take color buffer and texture slot. And then for binding depth as texture, we just call on the exact same function that we did before. Texture slot. As for this, binds slot to so gl active texture 0 plus texture slot gl bind texture gl 2d gl bind shader, it's just shaders index bind, and then last but not least gl use program gl none. And that is it for our post effects. So now, if you remember what we had to do, we're gonna, obviously you can pause if you need, but if you remember what we had to do last time for our frame buffers, we had to go into BackendHandler. Specifically, we had to go into the window resize and add frame buffer. Well, we have to do that again. This time, we want to tell it to do post effect. Obviously, we haven't included post effect yet, but we will. The running is the exact same because they both have the exact same functions. So we got to go into BackendHandler.h, include graphics post effect. And there we go. And it's done. You are now resizing any post effect that you create. Yeah. No, yeah. That's it. That's resized now. Funnily enough, if we scroll down to where our test buffer was being created and just go in here, change that to post effect, change this to post effect. So this is the best part about post effect. it's so similar that it can literally just replace where you had a call to a frame buffer. It's done. That's a post effect right there. So now that we've created it, obviously we have to replace, because we renamed it to basic effect. Basic effect. And it's .bind buffer. And you have to give it the index. So we bind the first one, basic effect, unbind buffer. And then instead of draw to back buffer now, it's basic effect dot draw to screen. And if we run it, we gotta wait for it to build, obviously. Almost done. One thing that I am looking into adding also, it doesn't change anything. Because of the fact, and notice, we clearly have our post effect bound. This is a post effect. Doesn't change anything, because the whole point of a post effect is to not change anything. So, yeah. We can remove this, obviously, and obviously we will get exactly what we had before. That empty blue screen without anything drawn. The clear color with just this. It's all still being rendered on the effect. It's just not rendering to the back buffer. So we're going to take this. We're going to run with it. Remember how we set up that apply effect? Well, why don't we write our own effect? Why don't we write two? So today we're going to write Greyscale and Sepia. These are pretty simple. As I said, we did most of the stuff that we need in PostEffect. So the very first thing that we're going to write, frame buffer, overrides, post. So void init width inside height override applies the effect buffer passes the frame buffer width to as parameter. So we're going to override apply effect. So post effect buffer override. And then we're going to have getters. So with Greyscale, we have this thing called intensity. I spelled that wrong. There we go. Get intensity. Setters. Blue. Intensity. Private. Because this one isn't going to be inherited at all, we don't care. So now we just control period, create declaration / definition. Now we go to the CPP. We make it so returns intensity, and then intensity equals intensity. And then we initialize it. Notice how, we really didn't have to do a lot. And so the thing with Greyscale is we only need one buffer as well. So index equals buffers. The reason why this is overridden is because it is possible that with an effect we could want different things. So buffers index add color target. And so we want all the channels. And then buffers index init. Notice how we didn't put a depth buffer? So here's the thing. If you are rendering your stuff, if you were to change basic buffer, like basic effect, and make it into a grayscale effect, you will need a depth buffer. If you only plan on using it as a post-processing effect, which is how you should be using it, no rendering to it. It only renders to shaders. Then you won't need a depth buffer, if that makes any sense. And I'll show. I'll show what I mean to back up my words. Shaders, index. So I included two shaders that will work, but don't actually do what they're supposed to do. They won't crash though. That's another thing. I would like to possibly for next week's video implement default shaders. So have you noticed that whenever your shader doesn't compile, your game just crashes? Like you get an exception and it gets mad at you? Well, what if when your shader fails, instead, it just does the Gary's mod thing, where it just puts a purple shader on screen, where it just makes everything purple. This way, oh, sorry, just on autopilot. This way, you wouldn't have to completely rerun your program every time. And then what if I made it so that if I go in here into shader, if I made it so when you create it, it does a throw runtime error. Instead of that, if it doesn't work, or if the shader breaks, we simply just, I simply adjust it to give a default shader that just makes everything purple. And then we create a function that allows you to reload your shader during the runtime. And you can let me know how you feel about that idea. It is something that my GDW game had. It is something that everyone in my year's GDW game had. And the reason for that is when you're editing shaders, you don't want to have to run and rerun your program 60 times until you're sure that it worked. You want to be able to run it once and just reload the shader over and over again. Oh. Buffer. So we, our previous buffer that we passed in, bind color as texture. We're going to bind that first one because that's all we care about with Grayscale. We don't need any other buffers. Buffer 0. And then we render to full screen quad. And then we unbind texture at texture slot 0, and then we unbind shader. That's all. Your effect's been applied. It's that simple. It is that simple. And so the thing with this is, right now, if you were to do DrawToScreen using this grayscale effect, it would not actually what's the word? Render to your screen. It would not render to your screen as grayscale, I should mention. So remember how in our PostEffect, we made it so DrawToScreen. It's overrideable. So if we go to DrawToScreen, open that up, and we look at it, it's really not that different other than the fact that we're binding our own color as texture. So here's the thing with doing post-processing effects. You should never be changing the same buffer that you're drawing to. So your shader, so when you have this bind color as texture, you shouldn't be changing the same pixels that you're applying to. It can cause issues with some effects. With grayscale specifically, doesn't really matter. So we're going to implement it. So we're going to do screen. And this doesn't take in anything. So void override. And so this is an exception to the rule, not the rule. If that makes any sense, I hope it does. 0 dot to uniform, hue intensity, and then intensity. And bind color is texture. Buffers, draw full screen quad, unbind texture, unbind shader. So now if we go into Greyscale Effect, we have our DrawToScreen function, and it will apply grayscale before it draws to screen. And that's, that's pretty cool. So we can close up Greyscale Effect. What we can do now, actually, is go into BackendHandler and include Greyscale Effect. And if you notice, Greyscale Effect includes PostEffect. So we can actually just remove this. And if you actually notice, if you go to Greyscale Effect and then to PostEffect, PostEffect includes framebuffer and shader. We can just remove framebuffer. There's no reason to have it. Now, if we do this, so let's go up here. And let's grayscale. Oh. Grayscale effect, pointer, grayscale effect, game object, effect object equals scene. Create entity, grayscale effect, int width height, window. So what we can do here, you'll notice that we're repeating code. So what's the point of getting the buffer twice? We can just, about getting the screen size twice, if we can just do that. Greyscale effect equals and effect object dot in place, and then width height. So now our grayscale effect exists. So the first thing that we want to do, every single effect that you have needs to be cleared. And so we still have our basic effect bound. If we run it, gotta wait for everything to build. It's possible that this could fail because we haven't written the grayscale shader yet. That is the next thing that we need to do before we can actually have this draw anything. You'll see, still doesn't draw anything because we haven't drawn anything out. We are currently clearing our grayscale effect. We're not drawing anything to it. Now what we want to do is we're going to have to close this up, sadly. Because if you edit this shader for some reason, and I'm going to look into it, it won't update if you do things with it. Oh. So we are going ignore this. Ignore that. Again, I just have a thing in the background to make sure that I don't screw anything up. So this is lower the number closer we are to regular. Another thing that we want to do, just important point, so we want to go back to wherever this is. We want to make sure that we have our thing closed. We want to run clean. We want to program it. Sadly, right now, this is how you have to do it. I'm going to look into why that is. I believe it has something to do with the shared assets folder. And I am going to talk to your former TA about that and ask him why that happens. So float luminance. So luminance is the, I guess, basic color value of your screen. And this, in order to get this, this is basically you adjust the channels such that they're all of equal, what's the word? Standing, I guess. Because certain channels are more intense than others, we don't want them to be as strong, so we're multiplying them by smaller numbers. Green is not a very powerful color when it comes to RGB, whereas red and blue are extremely powerful if not diluted. Remember that blue light is, one of the strongest, as far as I know. But yes, so mix So this averages out the color on our screen, averages out the color in the pixel. And so what we're going to do is take this, turn it into a vector 3, which basically makes a gray, so to speak, which is why it's called grayscale. And then we're going to mix it based on the intensity. So if the intensity is 1, it's going to be 100% luminance. If the intensity is 50, it's still going to have some color, but it's also going to be shifting towards this. And then we just take the source alpha in the end, because the source alpha 9 times out of 10, if you need it to be different, you'll send it in as different, but it'll almost always be 1. So yeah, save that. That's our grayscale frag done. Yeah. Now we can pre-make build. Bring it back. Again, I'm going to look into making some improvements to how shaders are written, because this is kind of tedious. It's not that it's bad, it's just I don't like making this tedious. I want this to be fun. So remember that apply effect function that we have? So GreyscaleEffect.applyEffect, and we pass in our basic effect. And then GreyscaleEffect, or GreyscaleEffect.DrawToScreen. And so now this will apply our basic effect. Oh, I forgot to set this as our startup project. See, that's why it's tedious. Or part of the reason why it's tedious. Now we just gotta wait for this to build. I'm sorry that this is so tedious. It happens. Such is life. You know, it happens. Sometimes we gotta build things more times than we would like to. We are totally gonna end up with a shader error. Oh! Look at this, we didn't. But you know what's one thing we forgot to do? We didn't resize it. Very important. So gotta go to BackendHandler, go to our window resize callback, which is in BackendHandler.cpp. Control C, Control V, and just add grayscale effect. Now, there is a better way to do this, and I will show it to you. Closer to the end of the video, we are only about 2/3 of the way in. This video will be about 1.5 hours. But yeah, now if we run it, now it resizes. Works perfectly. Go up here. You also notice that these rocks only spawn in here. And you can look at the math for how to figure that out. It's cool. I think it's cool. Oh yeah, and the reason why this is so fast is all it does is re-randomize the numbers, and nothing is ever getting loaded in again. But however, you can dynamically add. I'm sorry, I get distracted. You can dynamically add objects to this list during runtime if you set up an ImGui thing to do it. You could theoretically add extra objects and remove objects from the generation during runtime. And all you do is pass in the file name of the object you want to remove, and then it'll remove it. Sorry, back on topic. So as you can see, this worked. But remember how I told you that if you aren't using Greyscale, like a Greyscale effect as an effect where you apply it, and instead are just using it as a basic frame buffer, watch what happens. Effect, bind buffer, and then it's already being cleared. So bind buffer, unbind buffer, and then DrawToScreen. Watch what happens. If you do not, and this will only occur if your Greyscale effect does not include a depth target. Now I figured I'd keep this in just to show you what sort of errors that you can get. So you'll notice it's just the skybox. And the reason for this is that the skybox actually draws last and draws on top of everything. The skybox draws itself on top of everything. So if you don't have a depth buffer, and then watch what happens if we buffers index depth target. If you don't have a depth target, it will if you don't have a depth buffer, OpenGL can't figure out that your skybox is meant to be behind these things. Because your skybox is the last thing drawn, it draws on top of all of this. Oh yeah, I just thought that was an interesting thing to include. You can leave in the depth target. I'm going to leave in the depth target. And I will be including it for Sepia Effect as well. So in most cases, so we wrote this and how it's like, it's okay. It works. This is only useful if you were doing it this way. So currently, if you switch it back to use, basic effect, and then we do apply effect, and then DrawToScreen, this applies the effect once, this applies the effect a second time. So typically, you don't want that. You really don't. So at the end of your effect list, you typically have a basic effect where you draw it to screen in a way. In this case, we don't need it because we wrote, my point is it's a trade-off. You can overload this or you cannot. In this case, I only showed it to you as an example. I don't want it there. It is not something that we are going to keep in my version of this. In your version, you can keep it. But this way, we'll still get the exact same effect. The effect will still render. almost done. We'll still get the exact same effect, and the effect will still render. It's just we won't be applying it twice, which is better for performance. You'll notice that applying it twice doesn't do anything for Greyscale specifically. And you'll watch if I click on this now, it'll send me to the PostEffect version. But yeah. So I'm just going to scroll back up to here and leave myself here. And next up, we're implementing Sepia. Sepia is a pretty interesting effect, to say the least. So the idea is that it's a certain percentage of the colors. And so it's sort of like, how do I explain it? There's no exact amount for Sepia. Sepia is a how do I explain this? Sepia is a color that exists because of a specific material. It's like the old-timey photographs. And all we're doing here is going to try and approximate the color that we get for that. And you can change any single bit of what you want to do with this. Like, you can change any of this. You can change any of the numbers. It won't necessarily be sepia if you change them too much, but you can tweak the numbers as you need to try and get a better value, like a better looking sepia. And so, it is literally the exact same as the other one. And you will notice this with all of your effects that use PostEffect. PostEffect. And then, so sepia also has an intensity value. And normally you do not want 100% intensity. Sepia is very intense. And then private. I normally go with like a crisp 7. Yeah. Notice how quickly we can write these now. This is a second effect. We're already halfway done it. Return intensity. Intensity equals intensity. Done. That's your getters and setters. They're done. So for sepia, again, we're just going to do this. It is again a 1 buffer effect. And you will see what a multi-buffer effect looks like when I show how to do bloom later on in the semester. So first, there, add color target. And again, we want it to have all things. Depth target, again, depth targets just in case. It's the performance that you're losing for having it is much less than the performance or the time you'll save by not worrying about running into that very simple error, or that very simple, I guess it's an error that I showed you before where the skybox renders over anything. Shading, push back, shader, create. Vert, GLSO, GL, vertex, and we're just gonna duplicate it, GL, fragment, shader, and then post, sepia, and then shaders. And that is your shader. Or that is your initializer. And now, as for applying the effect, find color as texture, render to full screen quad, unbind texture, texture slot 0, unbind, shader. That's all. That's everything. Now, what we want to do first before we forget about it is we're going to go to BackendHandler.cpp. Going to copy, paste. Going to go into the .h, include the graphics, post. Sorry, I pressed tab. Sepia Effect, BackendHandler.cpp, replace this with Sepia Effect, Sepia Effect. Now they'll all be resizing. We can go to main, create our Sepia Effect. Create entity, Sepia Effect, Sepia Effect, object.inPlace, and then width, height. And so, we can go down here, SepiaEffect.clear, and then instead of applying that, SepiaEffect.ApplyEffect, SepiaEffect.DrawToScreen. I don't know why I just built. Don't build. We have to close. To go in here, we have to clean. We have to go into samples. And again, this is tedious. I don't want to be doing this every time, especially if you're like editing shader after shader. You shouldn't have to go in here and do this every time that you want to be able to open up your stuff. You shouldn't have to. So, this is the intensity of the sepia effect. Lower the number. Sure. So, again, we did 0.6 before. And then for sepia is kind of like the luminance calculations, only it's a matrix, I guess. Use the dot product a lot. Equals source.r times 0.393 plus source.g times 0.769 plus source.b times 0.19. And then it's sepia color.g equals source.g or r times 0.393, or not 393, sorry, 349. So there are different percentages based on which one is being done. It's, again, you'll see what I mean by it being like a matrix. So it's the color of the screen times 0.686 plus source.b times 0.168. And then sepia color.b equals source.r times 0.272 source.g times 0.534 source.b times 0.131. And then remember that thing we did before with mixing? Well, we're going to do it again. .rgb and U intensity. And then again, going to keep source.a. And that's your thing. You can pause, obviously, and go back if you need. Remake it. Run it. Now that we're applying our sepia effect. Oh, it's going to build to GLF. Yeah, I always forget. Sorry if that peaked the microphone. That was a lot louder than I thought it was going to be. But yeah. See all these effects. And you've got your sepia effect. The last thing that I'm going to show, very, very last thing, is so we're going to take pointers and we're going to move them. We're going to move them all the way up here. As long as they still exist, that's all that matters. Went too low. Okay. We're going to do this really cool thing here. And we're going to do oh, hate it when I do that. So we're going to create an std vector of PostEffect pointers. And so we're going to use this thing called polymorphism. So, and then effects.pushback. Because this is a pointer, and because they both inherit from PostEffect, we can actually throw them into the exact same vector. In addition to that, we're going to set int active effect equals 0. So we're going to go down here, and we're still going to be loading in all these effects, and you'll notice that nothing changes about them. And because they're a pointer, this version right here, will actually affect the version that's in effects. So if we go down here, they're all still clearing. What you can actually do here now is comment this out and write like, this way you can keep adding I effects.size effects I.clear. Because PostEffect has clear, it doesn't matter. We can just clear it. And then if we do this, so effects at active effect, and then effects at active effect, we can go all the way up to our ImGui controls, add a new collapsible header, effect controls. ImGui slider, or is it slider that I want? Int. Yes, slider int. So we want it to be, so for the slider int, we make it chosen effect. Limit is 0, maximum is effects.size. Oh, sorry. I messed that up. It is and active effect. Sorry, I had a brain fart there for a second. Minimum is 0, maximum is effects.size minus 1. And so with this will already automatically switch everything that you want, but I'm going to go a step further. You don't actually need any of these if this specific if statement doesn't need an if. It doesn't need to do anything. It already does something by changing the active effect variable. So now if we do if active effect equals 0, you can do ImGui text active effect Sepia effect, and then if active effect equals +1, ImGui text active effect Greyscale. And that is pretty cool to me. And now if we run it, assuming I didn't screw anything up, oh, really? Interesting. Okay. So here's what we do. We just go down here. The solution to that issue is pretty simple. Just push the effect back after now. Also, moving Sepia on top. Effects dot push back Sepia effect. Now you can run it. Active effect Sepia. Active effect Greyscale. Sepia Greyscale. Sepia Greyscale. You can go one step further though. This is just me showing you how to effectively use ImGui, and you can use this in your next assignment for color correction, which is the last thing on our docket. So because we're in here, you can do if you can read in effects at active effect. Greyscale effect pointer. Effect pointer equals. So this just casts it back to a grayscale effect, and this will cast it back to a. This allows you to access functions like get intensity that you wouldn't be able to access otherwise. So temp, so float intensity equals temp dot get intensity. And then because Greyscale and Sepia both have the same. So what we can do here is if slider float intensity, the minimum is 0.0f, the maximum is 1.0f. And then whenever it changes, you just do temp dot set intensity to intensity. And because Greyscale and Sepia are nearly identical, just write this. If you run this, this shouldn't fail. It could fail because of these two. Could fail because they're being called before effects actually has anything in it. But it doesn't. And then we can switch over to the grayscale. Deuce it. And always switch to the right intensity. Yeah. Hopefully you found this pretty cool. These are just 2 effects that you can make. And these are just 2 cool ways that you can use ImGui. You can keep going with ImGui and create an entire thing that allows you to like swap between different buffers and stuff like that. I already have. Now, for the final part, this is for your assignment 2. This is very good, very, very, very important information. I would hope you stuck around, because if you didn't, you're not going to have fun. Because you aren't going to be able to complete your assignment. Okay. So, this is for the people that stuck around. So, color correction is part of your requirements for the next assignment. And so what I've gone ahead and done is implemented this. So color correction is done via the use of .cube files. This is a loader for .cubes. So what you need to do when creating them is, so you can go up here, and I actually included wrong file, right file. I included in week 4 resources cubes. I included a test cube that you can load in. They are not as fast as your other things. They cube because it's just a text file. A LUT3D test cube is it's just a text file, one that you can read. So cube file essentially treats color on your screen as coordinates on a cube. So if it sees red such and such, it will convert that red into whatever the cube says. Like if it's 1.0, 0.0, 0.0, it will convert whatever that color is and use it as a coordinate on your color cube. And so what you need to do to be able to use it is you need 2 little lines in a shader. And I'm not going to give you the shader, but I will show it for a second because I'm nice. I do have this shader done. Do have this shader done. I will show it for a second. That's all. If you can pause and catch it, more power to you. Make sure to pay attention where the bindings are, because you need to bind this. So this is a 3D texture. 3D texture. Sampler 3D is a thing. Sampler 3D. Now, if you caught that, I mean, you have a video. You can easily go back and get it. But I figured I would show you that. Now, as for making sure that you all are prepared to complete this assignment and make your own color cubes, I have gone ahead and found a LUT generator online. So, cut. Obviously, I did not mean to cut. There you go. So, this is a pretty easy thing to download. You just go to download LUT generator. It's $0. It's entirely free. You can just put $0. Press on buy now. You have to make an account. Or you don't have to make an account. I put $1 somehow. I did. Meant to put 0. Put 0. You just give an email and it'll email you with it. I have it downloaded already. Don't need this. Don't save. So I have it downloaded already. This is what it looks like. And I have an example one already in here. So this is your test one. I called it shifted 512. So we're going to go in here. So what this is going to do, So what this is going to do is generate. So generate a HUD. Generate your first one. I'm just going to generate it in here. Select. Gonna save. It's right there. That's your HUD. So what you then do is go into your game. Run your game. It's going to take a little longer because of the cube. We are going to be a little over an hour and 30 minutes. I apologize. This is important for your assignment, though, because if you don't have it, you can't complete it. It's going to take a bit. Still got to load in. So this is just, if we look at Let3D, look at load from file. It's just, oh, looks like I left this in. That should not be in there. Apologies. This is going to load infinitely. Make sure to go into Let3D and remove that, actually. Your LUT will not load in. Okay, so we're going to go in game. We're going to turn down the intensity 100%. I'm going to go over here. I'm going to take a screenshot of our game. I'm going to, oh, interesting. He has it set up so that I can't minimize. Interesting. Okay. Unimportant. I will just move it down here, out of the way, after I make it 0. So we're gonna take a screenshot. We are going to take a screenshot. There you go. We got a nice little screenshot. So we're gonna go into Paint.net or Photoshop or whatever you want to use. I'm gonna close this up. We are going to Control V, expand canvas, add a new layer. We're gonna open up our neutral, the LUT that we just generated. Open up the neutral version. Oh, lagging for some reason. Duplicate likes the amount of stuff I have open. Weird, never had that happen. But, you know, this is in our LUT. So open this up. We're going to Control C, Control V. Now it's on our new layer. I'm going to keep it this size, obviously. And so, obviously, we can hide it. So the way that applying effects works is, so if we go to Adjustments, go to Curves. I don't want to go to Curves. Go to Effects. None of these will do anything, I should mention. Maybe Glow will. Glow might. I don't know if Glow is doing anything. Oh, I'm on the wrong. I was on the wrong layer. There you go. Now I'm on the right layer. So, photo, sharpen. I believe sharpen, no, sharpen's a post-processing effect. So what you want is, so for color correction, it's specifically going into hues. So we're hue shifting it a little. Changing the saturation. Where's the one that I want? There's a way. So you go in here, you know, you can hue shift. Make everything nice and bright now. So this color correction, what I've done here is I've made all the colors very, very nice and bright, poppy. So you see these settings. So 44, 161, and -7. And, I can make it dark, or I can just keep it at neutral. So 44, 161. So, okay. So now we've applied this. So what we go here is after selecting the layer with our color correction cube on it, we just adjustments, hue and saturation. It'll automatically be set to both of the settings. Okay. Now this effect, the effect that we've just applied to this, has now been applied to this. So what we're going to do is we're going to select it, Control-C, Control-V, keep canvas size. And now File, Save As, Shifted, Brightened, Correction.png. I'm going to save that. See, now it's saved. I close this down. Don't save. So I got my brightened correction right here. Got this. So convert to cube. Brighten correction. Now it's converting it. Conversion done. Brighten correction.cube. And now I can right click, open file, close up this LUT stuff. Now I'm going to throw in my color correction one into this. Not going to push it. That's not getting pushed. I'm going to throw this in just to show you what it does. And then I'm going to go into my cubes folder, throw brighten correction in there. So brighten correction.cube. I'm going to go a little further up to where the shaders are being loaded. Load in shader. Correction shader. Create. Color. I'm just going to do this really quickly. This is just to showcase it to you. And then, so we keep pass through. Just need to make sure that I'm getting the right name. Now color correction shader is all loaded in. So we're going to go over here, just create a regular frame buffer because I'm not writing a color correction frame buffer. So frame buffer, color correction object equals scene, create entity, color correct, and then we want it to be a frame buffer, color correct, color correct equals color correct object dot place frame buffer color correct dot add color target GL RGBA 8 color correct dot add depth target, and then color correct.init width and height. Now if we go down here, gotta make sure to clear it. So color correct.clear, and so we're gonna, not use that. So what we're going to do here is one second. I already have this code written. No reason to write it again. Basic effect, find color as texture, and then test cube dot find sorry, this should be color correct. Fine. Apologies. Correct. Test cube. Unbind. And then color correct. There you go. Oh. It couldn't find the shader because I forgot that it's tedious and I have to clean and then pre-make. Feel free to skip ahead to where everything is properly set up. Startup. So I've set the cube, like the LUT, to bind to slot 30. This just makes it easier so that you don't accidentally have different textures in there and use those as your color correction. Just in case you forget to unbind a texture somewhere. Because if that happens, then you'll have a texture in the slot, and that's not something that you want when you're trying to do color correction. Feel free to skip ahead to where it's done. This video is running on 2 hours, sadly. Completely unintended. Next week should be shorter, hopefully. I aim to keep these under an hour and a half, but there's a reason why the tutorials are 3 hours long. And it's, this content is really hard to get through. Also, I got distracted a few times and did other things. Oh? Did I not? Interesting. Week 4. Resources, shaders, color correction.frac. Oh, forgot to add post. See, again, that's a thing that would be good if you had a default shader. Remember how we said everything became brighter? How close does this look to our image? But now it's from every angle. No matter where we look, it's properly edited. Doing this is the same thing as applying a filter to a screenshot of your game and then making it so your game recreates that filter in-game. Everything's brighter now. But yeah, that is the gist of color correction, and you should have more than enough with this video to be able to complete your assignment entirely. You can even take advantage of these effects for that purpose. But yeah, that is the end of the video. I'm going to end it here. I need to start timestamping it and going through and uploading the video. Have a great day. Have a great night. I look forward to seeing anyone with any questions on Friday. Bye.